All right, we're looking at trig identities, sine, cosine, and tangent, and dealing with reflections and rotations. Mainly, it's the idea of rotations going on here, but the idea of a reflection is kind of like a rotation. All right. So on the following circle, on the unit circle, theta is in terms of radians. Okay, they're not even giving us pies, but they are telling us radians. Okay. Without a calculator, so no calculator, evaluate what? The expression to the nearest hundredth. All right, let's see how this goes. So when dealing with these, the foundation here is tangent is equal to the change in y over the change in x. That's your slope idea. The tangent is also equal to sine over cosine. This is my foundation. This helps me remember that sine is equivalent y values and cosine is equivalent x values when we get into the idea of quadrants. And then we'll see how that goes when we do it. All right, let's try it. So they want cosine of pi minus theta. I like to start with the minus theta idea. So if this direction is positive, that's your counterclockwise direction. This direction is negative, your clockwise direction. So the negative on the theta means this theta, which lands in quadrant 2, if I start right here, I'm going to go past quadrant 4 and then land right here. Okay. So this is the negative theta. So that's negative theta. And then I'm adding a pi to it. A pi is a rotation into the opposite quadrant or diagonally opposite quadrant. So that would be, then we go back, positive direction, and we're landing right here. Okay. So when we think about this one, we're talking about cosine. Cosine is the equivalent x values. Okay. So this x value, so the answer to your problem right here would have been just cosine of theta is the x part. So that would have been the answer. But now we're in quadrant 1. So basically that means this part is 0.42 as your x part without the negative. Okay. So that would be positive 0.42 on that one. And I'll just say 0.42 and I'll write it in just a second. Let's do the next one. Oh, this one's the easy one. So 2 pi. So we go, this is pi, theta plus 2 pi. Okay. So we have our theta, we have that one already, and then we're adding 2 pi. What would that look like? Well, we're going in the positive direction. It goes all the way around and lands in exactly the same spot. So this one would say have that same x value of negative 0.42. So negative 0.42 on that one. And then I had positive 0.42 on that one. It's just getting used to having this foundation of are we looking at the x or the y when they're giving a sine, cosine, or tangent. Tangent's going to be kind of an idea of is it positive, negative, and then doing the rotations to see where it lands. Let's try the next one. All right. Okay, so we got a tangent, all right, and we're looking at the 2. So let's try that. Which 2 of these expressions are opposite of tangent? All right, what does opposite do? It basically changes the sign. So let's take a look at this. Remember, tangent is going to be y over x, basically, when we look at these. Okay, so in this one, it's positive x, positive y. In this one here, it's negative x, positive y, quadrant 2. In quadrant 3, We got negative x, negative y. And then lastly, we got positive x, negative y for our quadrants. Okay, so this one right here would give us a negative answer. So theta, so this implies that theta, tangent of theta, this implies that tangent of theta is going to be what? Positive or negative, right? Well, the negative and positive make this a negative. So this is going to give us a negative answer, y over x. Okay. We want which expressions are opposite of tangent. So opposite changes the sign. So we want this equal to positive y over x. Where is that going to happen at? Okay, so that's going to happen in quadrants 1. So we want to land in quadrant 1. And where else? Quadrant 3. Okay, so we're looking to land in these quadrants, and that'll answer the question. All right, and then we'll do the same thing about doing the rotations with the theta. First one, let's go through each. This is a negative theta, so negative theta. It's going to land right here. It's negative theta. And then what are we doing to it? We are adding pi over 2. So which direction does that go in? There's your positive. There's your negative. If I add pi over 2 to it, it's going to land in exactly the same spot. Not that one. We went opposite. We got negative theta plus pi. So here's my negative theta. And then I'm adding pi to it. That lands right here. Hey, there we go. That one looks good. That's in quadrant 1. So that one's okay. We got positive theta plus pi. So here's positive theta again, and then we're adding pi to it. So we're going all the way around, and I'm landing right here. Is that okay? Nope. That's the wrong quadrant. So not that one. And then negative theta, and we're doing a full rotation with 2 pi. So negative theta was this one right here. And then I'm going all the way around, positive direction, and I land exactly in the same spot. Is that okay? Yes, Q3 is what we're looking for. Okay. So going through each one, making sure we understand it. And this looks to be a similar style problem. So you would do a this one's pretty easy, right? Anytime you're adding 2 pi to the positive, is you're landing in exactly the same spot. Sine, is that x or y? That's your y. So that's going to be your answer, negative 0.96 for adding it. And then if I go the other direction, so this is, it lands in quadrant 4, right? So if I go the other direction, it's going to land in quadrant 1, right? All right, so for sine, quadrant 1, the y values are going to match. So that's going to be the same y value right up here, all right? So that would be a positive 0.96. Positive 0.96 for the y value up there in quadrant 1, and then negative 0.96 for the full rotation. .96 and negative 0.96. All right, so it's just getting used to what are we looking at, x's or y's, and going through them. Last one, just to see if it's any different. What is the opposite of cosine of theta? So it's that same idea is you'll map each one of these, seeing what quadrant it lands in, focusing on the x or the y. And then, of course, we're looking for the opposite for the answers.